Word.
Okay, let me share my screen. Okay, so hello everyone. If you guys remember from last time, from when we went over function definition, for loops, and conditional statements like the if, else statements, we're gonna complete this activity at the end, but we kind of ran out of time, so we're gonna do it like right now, just real quick before we get into um, our topics for today. And it was a guess the number game, and these were the rules that we defined beforehand. We're gonna define a function called guess game. We're gonna let a player guess a secret number, give them 3 tries to guess that number, tell them if they were right or wrong, and stop if they guess it correctly, and then print game over when they're out of tries. And we're gonna use like the collection of everything we've learned so far, like for loops, the if statements, print, and the input function from before, the range function, and the comparison operators as well. All right, so let's just get into it. If you guys can open Colab for me real quick, um, I'll get started here. I'll give you guys like 30 seconds to get that open real quick. But we'll just start. The first thing you want to do is just defining your function, right? So you want to let's do define guess game. And if you remember what I said about parameters, in this instance we don't need any parameters. And okay, so based on our rules here, we want to have a certain number that we want our user to guess. So let's just choose a random number. Let's say we have a secret number, secret, and we assign that the value of, let's say, like 7. Remember, the equal operator is just for assignment. Double equals is for actually making it equal to something. But yeah, for now, let's do that. And what we want to do is give our user 3 guesses, a certain number of guesses. Do you guys have any ideas on how we can do that? Like, we give them a chance to guess once, and then if they get it wrong, then they have to guess again. If they get it wrong, they guess again, like 3 times, right? So, do you guys, based on what we've learned so far, what should I use to kind of do that kind of thing? If you guys just want to put it in the chat or something. Yeah, you would want to use input and you would want to use a for loop, right? So what you want to do is you want to start off with a for loop, right? Because you want to give them, you want to ask them their input for each time, right? So let's start with for attempt in, and what we can do here is because we're giving them 3 guesses, right? We want to use the range function like before. And then we can give them 3 guesses here. And in this for loop, what we want to do is we want to give them a guess and we'll assign that the input value of, let's just say, let's just ask the user to guess a number, right? And when the user guesses a number, we want to compare it to our secret number, right? To see if they got it right. So how would we do that? If you guys want to put it in the chat, like from what we've learned so far, what can we use to do that comparison? I'll give you guys like a second to put it in the chat. All right, if damn, I get okay. If you guys don't know, then I'll tell you. We'll want to use the if statement, right? For when it comes to comparisons and things like that. So we'll do if our the guess the user does, right, from here. if the guess is equal to the secret that we assigned before, then we can write a print statement essentially that says, okay, like you're correct, right? And we can return from that because remember, you want to return in your functions. And then we can write an else statement. If they don't get it right, we can print something like that was the wrong guess, right? And that's only for things inside the for loop, right? So what happens when you're out of tries? You're out of this range three. Like once you iterate over each attempt in the range. So once you're past the third attempt, we want to also return something and print something for that as well, right? So what we can do is outside the for loop, we want to print like something like sorry out of tries. And it's key to make to have this outside the for loop because if we had it inside the for loop, this wouldn't be printed out, right? And then another thing that is key is that you want to call the function because you don't actually run it just by like defining it. You need to call it outside the function if you want to run it. So if we run this, then we'll see that, okay, let's run it in the cell. And then, okay, we'll see here the input, right? It asks me to guess a number, and then I'll guess something like 5, right? And then it'll say wrong guess, right? And then I'll guess another number, like 3 or something, wrong guess. And then I'll guess the correct number, which is 7. And um, wait, hold on, sorry. Can anyone tell me what I did wrong here? Because I guessed the correct number, but I still got wrong guess. If anyone in the chat wants to just like chime in, say what I might have done wrong here and why it's printing wrong guess. This one is a little bit tricky because it's not super obvious at first, but yeah, exactly. The secret is an integer and the input is a string. So that is a type mismatch essentially, because when we assign secret the value of 7, that's an integer. But when we ask the user for an input, it returns a type string. So when I compare the guess that the user makes to the secret, it's comparing an integer and a string, and that doesn't line up correctly. So what we want to do is we want to convert the input that the user gives to an integer. And the way we can do that is by just putting int at the front here and put parentheses around the entire thing. So now it should run fine. So if we guess 7 now, then it'll say correct. So that's another thing important. You want to make sure you're always, when you're comparing things, you want to make sure that the type you're comparing, like the data types, actually match well. So yeah, now it should run properly. And that's just a quick little function definition um, that we are going to do from last time activity. Um, so yeah, hopefully you guys, that's a good refresher and understanding now of like how for loops work, how if statements work, print input functions, comparison operators, things like that. Um, if you guys have any questions, let me know now. Like if anything was hard to follow, if I was going too fast. If not, then I'll move on to our topics for today, which is data structures. And this is like very important and integral to um becoming a good programmer in general. So I'll give you guys a few, like 30 seconds if you guys want to ask any questions about the function definition. If not, we'll jump right in. Okay. I think everyone's good. Okay, good. Okay, then we'll jump right in. Okay, so what is a data structure, right? A data structure is a way to organize, store, and manage our data so that we can use it efficiently. And we have some key operations that we can do with data structures. Like we can look up things really fast, right? We can insert things into these data structures and we can delete things from them. But the key thing to remember is that it helps us with organization as our programs grow in size. Like the bigger our program gets, the more important it is to organize our data. And data structures help us do that in a very organized manner and efficient manner. Okay, so there are four like core abstract data types. We call them ADTs that I'll go over today. And there's like more that I can go over later, but these are like the core ones that we'll go over. So there's the sequence, there's mapping, there's unordered ADT, and there's a fixed sequence ADT. And this table, it kind of like illustrates like the differences between each of them and like what their use cases are kind of. Like, so for a sequence, that's like what you've seen in math, probably like just a regular ordered sequence, right? Like one, two, three, four, five, like things like that. But it's important to note that sequences in terms of like coding and our data structures, um, one thing to note is the mutability section. And mutability is essentially just like, can you edit or can you change the data structure? And when it's mutable, that means that you can. If it's immutable, that means that you can't. It's fixed, right? So you can notice that's the difference between the sequence and the fixed sequence is that the regular sequence is mutable. So you can change it. You can like change certain elements within it, but the fixed sequence, you can't change anything within it. And another thing is duplicates. Sequences can have duplicates, but you'll see things like mapping and unordered ADTs. Those you can't have duplicates. You want to have uniqueness when it comes to those. And what I mean by uniqueness is you want to have just one of each, right? That's what unique kind of means. And with fixed sequences, you can have duplicates. Like it's very similar to a sequence. The only difference between those two is the mutability. And yeah, here are some use cases for each. For sequence, you would have an ordered collection or an iteration. Mapping, that's more so like looking things up with a key. So maps essentially have key and value pairs. And we'll go over this how they work in Python later with Orno, but that's important to note for now. It's like you map a key to a certain value. And yeah. So that's a quick overview of abstract data types. And here's like an here we'll go over like when to use which one, right? So I'm sure you've heard of these lists, tuples, dicts, and sets. But when I was referencing the ADTs from earlier, it's like essentially what these are. A sequence would refer to a list kind of when it comes to like programming. And this is like when order matters. You want to have things like in an orderly fashion, and you need to insert and delete things by certain positions. So you can't really edit the position, or you don't want to edit the position as much, but you want to edit like certain elements within it. And then we have the fixed sequence from before, which is a tuple. It's like a list, except it's when you need the data within it to be constant and not change, when you don't want to edit any of the elements within it. And then for the mapping, we have that would be a dict or a dictionary, right? It's very similar to like a dictionary in real life, right? Where you look something up within it and you find a definition. It's very similar here. You have a key that you look up and then it gives you a certain value. And then we have the unordered unique, which is a set. And then essentially with a set. when we refer to unique, we want it to have no duplicates, right? So that's the difference between that and a list. And then another benefit to having a set is fast membership. And essentially what this means is like you want to ask the question, is this item already in my collection, right? If it is, then it's not a part of the set because then it wouldn't be unique anymore, right? That's kind of the key differences between each of the different types of data types and data structures. And here are some of the like core kind of operations when you want to reference these data structures, right? You want to access certain elements or look up certain elements. When you're looking through like a list or something, you want to be able to look something up within the list in a like really quickly. And that's why we have a list. You want to be able to insert things into the list. You want to add things to the end, which is like to append something, and you want to be able to remove things. Another thing is you want to be able to traverse through things, right? And traversal is like just being able to go through each element and then uh, doing certain operations based on that. You can use your comparison operators, you can do things like that, but traversal is just going through the list or the data structure that you have and just iterating through it kind of. And the membership test, like I mentioned before. Um, so now let's think of some like real world examples, right? Um, and I want you guys to answer in the chat, like, we'll go one by one here. Like, when would you use a list? And it's important to note like the differences before. Like, you want something that's like key to using a list, not like a set or a tuple. Like, what instance re in real life would you specifically need to use a list, do you guys think? I'll give you guys like a second to answer, like in the chat, like just some real world examples you guys can think of when you would want to use like a list or like something like that. Yeah, grocery shopping, that's like a really common one. Yeah, remembering what to do, like a to-do list, right? Yeah, those are two really good examples of just like when you want to use lists. How about like a dict or a dictionary? Like when would you want to have like a key mapping to a value, like where you look something up in like a book or something, and then you find out like you get a certain value from that. Like, what's a real life instance of that? I'll give you guys a second to answer that one too. This one might be a little more like difficult to think about, but yeah, UCI parking tickets. That's a that's a very true statement right there. Organizing bookshelves. Yes, that's a good one too, right? You want to have a certain you want to be able to look things up really fast when you're organizing bookshelves, right? Another one could be like a phone book, right? This probably way before this even before my time to be honest, but like in the phone book, right, you would look up a certain person's name and then um when you look it up, you would see the value of their phone number, right? So that's an example of like a dictionary. Yeah, username and password, exactly. What about like when would you want to use a set? Like in real life, an in real life example of like when you would want to use a set. Because like a lot of things you might think you would want to use for a set are actually like overlapping with a list, right? But you want sets to be unique. That was the key difference between sets and the other data structures. I'll give you guys a second to think about that right there, the uniqueness. Yeah, sets aren't too frequently used, but like they have their uses sometimes, you know? Like maybe like you want to send out like emails or something and you don't want like duplicates or like yeah, something like that. And you want to just make sure of that, then you can use a set. Just like instances where you want to make sure there's no duplicates of something, right? Um, what about a tuple? Remember, a tuple was like something you don't want to change. It's immutable, like where you don't want the data to change, kind of thing. Like, or even an instance where you might be like coding, for example. Like, think about that, like where you don't want like your data to change because you know it's gonna stay the same, like no matter what. Or like, yeah, just like what things do you guys like instances in real life? Give you guys a second to think about that one too. Yeah, I'm not gonna lie, a list is a lot easier to apply to real life than the other ones, but the other ones will have their uses when it comes to programming, trust me. Even though list is the most common and a dictionary, but the one instance I can think of, yeah, exactly. Running a script for a satellite and having a fixed amount of characteristics about those satellites, right? Yeah, the keyword is like fixed, right? It's not going to change. So when things don't change, that's when you want to use a tuple. And like you need to know it's not going to change. Or like a thing like maybe you're like storing like, I don't know, the 7 days of the week or something, right? Like that's never going to change, right? Like Monday through Sunday. Like if you have that just like listed that and you know it's not going to change, then maybe you want to use a tuple for that. Yeah, programming a robot maybe. Uh that's actually interesting. It depends. Like certain features maybe you don't want to change, but like other features maybe you want like um maybe you want it to like react a certain way depending on like certain like things you do to it, right? So that could change, but um there are instances where yeah, certain features you wouldn't change, right? Yeah. That's a good example, yeah. But throughout all this, it's just really important to know the differences between each of these data types so that you can use like the correct one depending on the situation, right? To be as efficient as possible. Because that's the name of the game, right? Efficiency, like really good programmers, and that's what people want. They want really good programmers, and you become a really good programmer by being an efficient programmer. And for example, if like you accidentally use a list where you might need to use a tuple and then you like accidentally edit the list, right? Then you might like end up like altering and destroying the data by accident because you used the wrong like data structure in that instance. So it's really important to use the correct one in a specific instance. Um, so yeah, I just wanted to get that across, but okay, that was everything I had. Orno, you can take it away. Don't want to take up too much of the time.
All right, so now we're going to be looking at how this looks like in like how lists and tuples and dictionaries look like in Python. Oh, wrong slide. Um, Here. So lists and tuples, they're very similar. Lists use the square brackets while the tuples use um, parentheses. And again, each item in the list or tuple is separated by commas. So for in the example, right now it's just numbers one, two, and three. But we have the name of the list or the name of the tuple, very simple names, equals, and then we have brackets. For the tuple, we have parentheses, and then for items one, two, and three, they're all separated by commas. Pretty simple. And an empty tuple or an empty list would just be the square brackets. So if I switch here, if I make a list, so my underscore list, if I want an empty list, just just brackets, and then the same thing with the tuple. So that's empty. But you generally don't want to make empty tuples because you can't change them, right? So whereas with a list, we said before we can change and add to the list. So for example, if we had a list of we're collecting data, right, throughout the days, so amount of rain per day, right? So the benefit of the list is we can add stuff to the list. So every day it takes some data, for example, and then we could be like add it to the list. and then we keep adding and adding. But the tuple, we want a set amount of days. So like Cheyenne said, maybe we have Monday, Tuesday, and then Wednesday, Thursday, Friday. And yeah. So that's how you make a list or a tuple. And I guess I answered this already. But review question, what's the difference between a list and a tuple? You can, unmute yourself, put it in the chat. This could be syntax related. This can be the function. What's the difference between a list and a tuple? Um, like a use case wise. And yeah, I guess those are the two things. What's the difference syntax wise and how we program it? And what's the difference in the application? I'll give you a second for that. Yeah, exactly. So in a list, you can change things, you can add, you can take away, but in a list you can't. And then what's the difference between a list and tuple and how we program it in Python? How do they look different, when we code? I will go back. So the difference is a list uses the square brackets and a tuple uses parentheses. So now how do we access the different values in a list and a tuple? Um, it's called indexing basically. So how we do it is we're going to use square brackets again, and we can address certain values of the list by just calling the name of the list and then the corresponding numerical value. So for example, here we have a list called X. It just says hi, hello, and bye. And then we're printing out the second value or the two value. And funny thing how lists are indexed, so lists and tuples are indexed in programming in general, is they actually start at zero. So, and I think you guys ran this through the for loop, so you guys know. So the zeroth term is that first term, or the first term is the zeroth term. The second one, hello, is addressed by one, and then bye is addressed by two. So when we say print x2, we're basically saying print bye, right? 0, 1, 2. Even though it's the third term, um, we're going to address it using x2. And this is the same for lists and tuples. You're just going to use like name, uh, the square brackets, and then the numerical value of whichever one you want to use. And then, as we mentioned with lists, you can add and remove things. So here, I'll list off two methods that we can use, but there's so many methods with lists, and I encourage you to explore those in your free time. But if we want to add, so we had the list from before, x equals 1, 2, 3. Say we want to add 4. We use the dot append. So this is like one of the built-in functions in Python. So we just use the name of the function, and then we add dot append at the end, and then whatever value is we put in the parentheses. This is as a parameter, like we discussed as for functions. So in the parameter for dot append, we'll put in 4, and then this is the output after I printed the new x value. So now it's 1, 2, 3, and 4. Pop does the opposite. By default, if you just run pop, it'll get rid of the last value. So from before, our list has 1, 2, 3, and 4. We took out the last value, and now it's just 1, 2, and 3. Another thing is we can also index with pop. So if we want to get rid of the first or the one term or the two term, we can just by putting it in the parameter for pop. So here we have 1, 2, and 3. X pop 1 gets rid of the one value. 0 is, or this one is 0. 2 is 1. 3 is 2. So when you say X pop 1, we're getting rid of that second value. So now it's just 1 and 3. And then there's different methods as well. Remove, insert. You can reverse the order of the function. Um, we're running low on time, but I'll show you where you can find these. You can just search up Python list methods, and then ChatGPT got you. So yeah. Um, Or what is this? This is not ChatGPT, but anyways. So like it's right here, and you can use these. W3 Schools is also a good resource. And then yeah, these are all the different. I'm sure there's more, but these are all the ones you are that are useful. Clear the whole list, and then you click on them, and it shows you examples. So yeah, there's that. Lists, you can also have multiple data types. So for example, we had numbers first, so integers, one, two, and three. You can also have strings, so hello, AABEA chair, booleans, which I don't know if we covered, but basically they're just true and false. And then you can mix data types as well. So in this one, we have all three of these data types in a single list. Um, and this is a like an extra application of lists, how we can use lists. If we combine them with the for loop as we did before, we can get some interesting behaviors. And this is a very, very basic one, but if you want to print each value of the list in order, um, so before we kind of just printed it out, and then we kind of got this as the output, right? We have the brackets and it's all in a row. But if you wanted each item on its own in a line, for example, like apples, bananas, oranges, blueberries, like this, um, you can actually use a for loop. So again, we're just gonna be, you guys know the syntax. Um, we have for your random variable and then in whatever range of items. So in this case, we used for x in fruits. And I didn't put it here, but right now the fruits list just consists of apples, bananas, oranges, blueberries. And every time it runs this print function, x is just the value of the thing in the list. So x for that first iteration is apples, prints apples. Second iteration, it's bananas, etc. Um, and then for this next for loop, it does the same thing essentially. However, if you recall, this one is indexing through the list, so the actual values of the list. However, this one it uses that in range, right? So we're indexing through numbers. And the method we're using to grab numbers, like the numerical value of each one, so apples being 0, bananas being 1, oranges being 2, we're using the this len method. So if we go over here and go here, let's do so len basically just grabs the length of the list. So len amount of rain, right? So this is the essentially the number of items in the list. And if we just put that in a print statement, I can show you how that looks. It's going to take a second. Yeah, this is unfortunate. 4. Okay, cool. So it prints out the exact number of items in that list. So that's the value of len, and then the parameter would be the list. So as you know, if we do for I in a range, whatever number, it's going to iterate. Like for example, we had 4 fruits. It's going to iterate between 0 and 3. 0, 1, 2, and 3. And then again, we know that from beforehand, um, to access a certain value in a list, it's just list, the name of the list, square brackets, and then the number of which we want to iterate through. So this 2 is the third value. Same thing in this for loop. Every time it starts at 0, it's going to print fruits 0. The zeroth value for fruits is apples, and then 1, 2, and 3, etc. So these two do the same thing, just in a different way. All right, so a little pop quiz. This one's calm. What's the index value of oranges? So right here, fruits, and this is the same list as before that I didn't have listed out. But yeah, just a little quiz. What's the value of oranges? So we have C, C. Seems like everyone agrees. I like that. Yeah. So the index value of oranges is 2, because again, even though we have 4 values in the list, we start at 0. So 0, 1, and 2. And yeah, keep going. Sets is like the same thing as almost the same thing as a list, um, or the way we write it, except it uses the curly brackets and what's it called? And it uses the same commas to separate each value. And again, as we can remember, sets are unordered, so we can't access it like lists. Like we can't just use set one, set two. We can't access certain values. They're unchangeable, and there's no duplicates allowed. So if you can see here, when I define the set, we have red, orange, yellow, and then orange again. However, when it comes to actually using this set, they'll actually nullify this orange in Python. They'll do it on its the program will do it on its own. So essentially, this set only consists of three values, even though there's four because we have duplicate. Um, yeah, so this is the same case if we have a bunch of emails and someone puts a duplicate email. For example, you know how like you put out a Google form and then some people will do it twice just in case. When we get that case and we have two different email or two of the same emails, if we put it in a set, then just like in this case where we have two oranges, it'll nullify the duplicates. And in practice, it's just red, orange, and yellow, or three emails instead of four emails. The dictionary, which is a little more complicated in how it works, the same thing, it has curly brackets. However, each value that's separated by a comma is there's multiple components. Each value of the dictionary has two values in itself. That was kind of weird. So if you can see, each value that's separated by a comma kind of has like this two components to it. So for example, we have brand and then Ford, comma. So that's kind of its one little value. The next value is model and then Mustang. And yeah, so each value is formatted as the key and then value pair. Or that's the formal name for it. But essentially, it's like when you're looking up in a dictionary, you have the word and then the definition. So you can think about it as word, colon, definition, and then comma, and that's a little pair, word, colon, definition, comma, etc. And that's how you use a dictionary. Again, just like the list, the dictionary has built-in methods, and there's a lot that you can just search it up on Google, dictionary methods. But here, the most practical ones, or there's a lot of practical ones, the easiest ones are accessing an item. So just like the list, if we use the square brackets, instead of using numbers, so in this case, beforehand, we had this dict, to access a certain value, instead of indexing it through 0, 1, and 2, which kind of defeats the purpose of a list or the dictionary, we can index it through the word or the key, right? So if I wanted to grab the brand of this, so this dictionary should be labeled car, but if I wanted to grab the brand of the car, I can simply go car or this dict, square parentheses, and then model, and then this would spit out Mustang, right? Because model corresponds to Mustang. And if we had this dict year, for example, we called the year, it would spit out 1964. And if we had brand in here, it would print out Ford. And then to add a key pair, so to add like another word in diction and mean and definition combo, we call the name of the dictionary. So right now it's car, but again, I've a little mismatch. We can put it up here. So if you have a car equals and then for example, if you wanted to add something, we would do car. We can address it using square brackets and then the name, the new key or the new word that we want to add. So color and then the key value or the definition, right? White. So that's how that looks. And yeah, the formal syntax is you would have the name of the dictionary, the square brackets, the name of the key you want to use, and then the value pair attached to that key. So again, name, and then you kind of, if we're using the dictionary analogy, the word in the square brackets, and then equals um, to the definition. And then essentially, if we run this, didn't print. So this will print car before the change and print car after the change. You can see before we just had the model number, so model 4 to 1876. I don't think they had Fords back then. But then after we added another key, so color and white, we have a new one, right? Color and white. So yeah, this essentially is how you add values to a dictionary. And what's the application of this? So beforehand, I was me in the chat. You can put like a username and password combo as far as for login info. So right here, we have a dictionary, and then we have example username and password. However, when you first set up an app or like when Facebook first came out, they didn't have any usernames and passwords, right? So they probably had an empty dictionary, or you would have an empty dictionary of some sorts. Maybe you would preload some profiles, but empty dictionary. And I think beforehand, you guys learned how to use the input function. So in application, I just made a function that asks the user for a username and a password. And then if you look at the syntax, the name of the dictionary is login info. After the user inputs their username and password, it would add username and assign it or assign password to username after adding it in this little thing. And if you guys want to check it out, I did have a little thing. It's in the Discord too if you want to check it out. But this is the whole script to run the login info stuff. But essentially all it does is it asks the user, do you want to sign in or do you want to create something? Create an account. If you want to create the account, it runs this function where it asks the username for username and password. And then if you want to log in, it asks the username what your password is, what the username is, what the password is. And then it uses a series of if and else statements to compare it to the values in the dictionary. But yeah, I think that's about it. Does anyone have any specific questions? Okay, so what I recommend everyone does this week actually is let's see, let's look in the docs. Um, there we go. So if you go here, week 3, we have this series of activities. I encourage you guys to go through the beginner activities, and then if you want, move up to the moderate level. So basically, the moderate just is just an addition to the beginner ones. Um, these are really good practice. And again, this is what I did, but I figured if you look at next week, we're talking about file handling and error management. But if we look at file handling, this is where we can make text files and then save it on your computer. So this is actual practical stuff. So right now, if you do the username and password stuff, it kind of just saves on the memory, and then after you terminate the program, it's all gone, right? But if we save it in a text file, we can, even though the program shuts off, we can grab it later. So the thing with if the login system is this is a perfect setup to add file handling to it. And since you guys are um, just learn how to use dictionaries and lists, if you actually make the login system this week, next week we can make our jobs easier and just simply add the file handling onto the login system. So that's an activity I recommend, and you can just, the answer is right here, available to you guys in the Discord. But there's also other ones like create a shopping list, right? So one of those if you can read through yourself, but we'll outline the shopping list activity for now. And I don't have time to walk through it, I guess. But as far as the outline, if we're making a shopping list function or shopping list program, you would first have a shopping list, right? Creating empty shopping list, right? So we have a shopping list, and then it's empty because nothing's in the shopping list. You want to make a function to add items, a function to remove items. And again, this is kind of, you can use the standard built-in functions right here. So we have append to add an element to the list. So if you want to add oranges, you can just append, and then in the parameters, the string oranges. If you want to delete them, you can use pop, you can use remove as well, figure out how to use those. and then a function to view the items in the list, right? So you can just do print the list, and that would have the ugly square brackets in them, or you can use the for loop that we mentioned back here. You can implement the for loop, which prints every item in a beautiful way. And then it's called so define a so you view list, and then now we need to create a way to interact with the program. So I think like Cheyenne exhibited before, you can use a series of inputs. You can use a while loop um, to actually get the user to say, I want to add an item. So ask the user for like three different inputs, right? So you can say like type add or type remove or type view, or we have exit program or type exit. And then say if the user types exit or types add, then it will run the function to add an item, right? So then it'll ask the user, what item do you want to add? And then it'll add that value to the list. So yeah. So what I do recommend is you guys actually do this one, and then you can share it in the Discord if you have any questions. We'll be here. Um, and yeah, I do recommend we start using the Discord a little more because it's really helpful to just collaborate on these sort of stuff. Like you don't have to work on it alone and coding away at this. It's boring right now, but yeah. So yeah, I do recommend you go through this list of, or it's basically outlined for you. You just got to implement it and you can just go through the slides and then pair it with some Google searching, some ChatGPT. You should be on your way. But yeah, any questions regarding this? And if you do have any questions, you can send an email, send a little question in the Discord. Feel free. And then I did get from last week, I got like three people to send me the activity, which was really good. They all did really well. Um, I think it's called. I'll call Zafir out because he did post it in the Discord, but he made a little. Once ago, what do you do? Calculated the area and perimeter. So let me share that. Yeah, so he made different functions to calculate the area and perimeter of a rectangle, triangle, and then a circle. So we had these three different functions, and then yeah, well, I think he updated this too. But yeah. So basically, if you run the rectangle value, it'll return length times width, and also the perimeter, so 2 times length plus width, and etc. You can go through the circle values. And then on top of that, he also did he asked for the input. So yeah, he used case statements instead of if statements, which is completely valid. It's cleaner in Python this way. But yeah, beautiful program. Let's run it, see what happens. Okay, this is gonna take a second to run. Oh no, there it is. Run it. See, so let's see. Yeah, so we can just say, let's see, we want to do area of rectangle. What's the length? 7 with 6. Should spit out. Yeah, 42 for area, 26 perimeter. So very, very lovely program. But yeah, so feel free to put that in Discord, ask questions or anything. But yeah, that's it for me. If anyone has any questions, anything they want to share.
Excellent class. I just want to add, like, I've been a software engineer professionally 25 years now. We still deal with data structures like every day. So what you learned today, if you go into the computer science, profession or background, this is going to be really important. And like, I'll say like whatever feature comes out at Apple, 6 months before we'll start designing the software features, and we will have a data structure review meeting kind of with multiple engineers, and they will go through like maps, lists, sequences, sets, and kind of go over, did you choose the right data structure to solve the problem? So everything you learned today, really important, and please go back and make some, exercises on your own if you can. Thank you, Cheyenne and Orno. Great class. Love it.
Yeah, yeah, and you guys are free
Thank
to
you.
go. Thank you guys for coming. And again, I do recommend you practice them because you won't know like the intricacies unless you actually apply them yourselves. And then when you get into the AI stuff or using those libraries and stuff, the just being able to be proficient in programming will just make your job 20 times easier. But yeah.
All right, see you guys next week. Take it easy. Bye.